This is not this one. Okay, settle down. We are starting the class again. All right, not from scratch, but we will be revising what we went through. So before that, I have a question for you. Raise your hands if you know what cos 150 is. How many of you know what cos 150 is? No one, right? I mean, practically no one. So I will be teaching you as a start how to take sine and cos of angles greater than 90. So I presume all of you know what sine 60 is. If you know, raise your hands. So what is sine 60? Root 3 by 2. Okay, that is correct. So the way we understand what angles above 90 degrees are, or their sine and cos are, essentially we draw a graph. All right. And the hypotenuse, listen, don't talk. We draw a graph, and the hypotenuse of the triangle, we draw a straight line, right? A straight line which rotates in the anti-clockwise direction about the origin. For instance, um, we have a line which will rotate like this in the anti-clockwise direction. You understand? This is going to be the hypotenuse of the triangle. Now, if the angle is less than 90 degrees, if the angle is less than 90 degrees, you probably do know how to find the sine and cos of it, right? You drop a perpendicular to the x-axis. You drop a perpendicular to the x-axis, and this is going to be the angle that you are concerned about, right? This is theta. If the hypotenuse has a distance of, has a length of r units, and this coordinate is x comma y. What does that mean? This is y and this is x. Can you tell me what is sine theta? Can you tell me what is sine theta in this figure? Can you tell me what is sine theta? Y by r, right? Sine theta, quite simply, is y by r. And what is cos theta? What is cos theta? X by r, correct. And what is tan theta? Y by x, correct. So the way we understand angles above 90 degrees is we use something called a reference angle. So if I have an angle, for instance, let's say this angle, I have rotated it in the anti-clockwise direction, and I have taken this to be greater than 90 degrees, somewhere here, all right? The angle in consideration, since I have rotated anti-clockwise, the angle is positive. If I rotate clockwise about the origin, the angle is negative. Since I have rotated anti-clockwise about the origin, This is going to be phi. All right. This is the main angle we are concerned about. To calculate the sine and cos of phi, we use something called a reference angle. The reference angle is the smallest angle made with the x-axis, right? So which is the smallest angle made with the x-axis right now? 180 minus phi, right? This angle, which is 180 minus phi, is the smallest angle that is made with the x-axis, right? So did you understand the concept of reference angle? What is a reference angle? It is the smallest angle made with the x-axis. Doesn't matter which direction of x-axis. So when you took y equal to mx plus c in coordinate geometry in your 10th, m was the slope in the positive direction of the x-axis. Do you remember? Do you remember? So we are quoting something else that you learned in 10th standard maths, right? You took the equation of a line. Do you remember? So in that, what was the slope of the line? The tan of the angle made in the positive direction of the x-axis, right? Do you remember that? You don't remember that. You studied coordinate geometry in 10th? You studied y equal to mx plus c? No. Okay, doesn't matter. Doesn't matter. This particular angle you take with any direction of the x-axis, but it has to be the smallest possible angle, right? This is called the reference angle. Now, as an exercise, I want you to tell me what is going to be the reference angle of 120? 60 degrees. What is going to be the reference angle of 95? 85. Correct. So what is going to be the reference angle of 300? No. So in order to find the reference angle of 300, let us first draw it. Okay. So these are your x and y axis. And where will 300 be? It will be somewhere like this, right? This will be the hypotenuse. This will be the hypotenuse. And this will be 300 degrees. Correct? So what is going to be the smallest angle made by the hypotenuse with the x-axis? 60, right? The reference angle is going to be 60 degrees. So what is the reference angle of 370 degrees? 10 degrees, right? What is the reference angle of 730 degrees? 10 degrees, right? Did all of you follow? You didn't. So can you tell me where 730 will be? So 360 into 2 is 720, right? So 730 degrees will be like this. What about angle minus 30? What is the reference angle? Minus 30. What is the reference angle? Minus 30 means 30 in the clockwise direction. What is the reference angle? Reference angle is positive 30, right? So you understand clearly how to find reference angle? You don't understand? So what is the reference angle of 160? No. 20, yes. Okay, moving ahead. Shall I move ahead? Okay. Now, let us for instance try to find the cos and sine of 120 degrees, right? How do we do that? Step 1 is we draw 120 degrees, right? Let's say this is 120 degrees. Okay. Step 2 is we drop the perpendicular. Like this we have, hey, don't talk please. Listen, we have dropped the perpendicular, it is fine. So let the hypotenuse be r. So this coordinate is minus x comma y, right? Along this direction we have moved minus x, and along this direction we have moved y. So what is, if this angle is theta, we will substitute 120 into it later. If this angle is theta, what is sine theta equal to? Guys, please don't talk, focus. If I go slow and you talk, it doesn't make sense. Okay, so tell me, what is sine theta equal to? Sine theta equal to y by r, because this is the triangle that we are concerned with, right? To find the triangle that we are concerned with, we drop a perpendicular from the other tip of the hypotenuse to the x-axis, right? To find the triangle that we are concerned with, we drop a perpendicular from the other tip of the hypotenuse to the x-axis. So the sine here is simply going to be y by r. But what about cos theta? Yes?
How did you get y by r? Because the theta is outside that triangle.
This is how we solve for angles greater than 90. Yes, theta is outside the triangle, but this is the triangle that we make, and this is the major angle, right? This is theta. We define it to be like this. All right?
So is there a formula to tell y by r? Like if the theta is inside the triangle, then it's opposite by hypotenuse, right?
Yes.
So is there any formula for this one?
The same thing, SOHCAHTOA. Opposite by hypotenuse is sine. Adjacent by hypotenuse is cos. Opposite by adjacent is tan. We stick to those principles, right? The only difference here is that the theta is outside. Okay, but what about cos theta? Is it x by r? It's not x by r, it's minus x by r. Because for this particular angle, the adjacent side has gone into the negative region. Did you understand? So if you notice, what is going to be the value of sine in this quadrant? For example, these are quadrants. I presume you know that these are quadrants. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Right? What can you tell me about the sign, about the whether it is positive or negative of sine, cos and tan in the first quadrant? Sine, cos and tan are all going to be positive in the first quadrant. Any doubt? No? So here all of them, sine, cos and tan are positive. What about in the second quadrant? So what about in the second quadrant? Sine must be positive. Yes? Hey, clowns, don't talk. Sine must be positive, right? Why? Because it is always y by r. Now r is always going to be positive. Hypotenuse is always going to be positive. Now y is going to be positive, right? So sine must always be positive. Yes? What about cos? Cos should be negative because the adjacent side is negative. What about tan? Tan will also be negative. So only sine will be positive, right? What about the third quadrant? What about sine? Will it be positive or negative? Sine will be negative. What about cos? Will it be positive or negative? You there. Cos will be negative. What about tan? Tan will be positive, right? You all can see why tan is positive? Why is tan positive? You. Yes, why is it positive? The question is, why in the third quadrant is tan positive? Don't tell me it's because it's in the third quadrant or because it's opposite by adjacent. No, neither opposite nor adjacent is positive. Both are negative. That's why tan becomes positive. What about in the fourth quadrant? Listen, clowns. What about in the fourth quadrant? Only cos is positive, right? Anybody unclear why cos is positive? Yes, because x is positive, y is negative. So sine will be negative and cos will be positive. Sine by cos will be tan, which is negative, right? So this is your mnemonic for you to remember which is positive in each quadrant. You can think of this in two terms. One, you can remember it as the cast rule, C-A-S-T, but you have to start with the fourth quadrant. The other thing you can remember is all silver teacups. You're friendly with cast, okay. The other mnemonic is all silver teacups, right? All silver for sine, tan t, and cups cosine. Clear? Did you note this down? Shall I go ahead? Okay. Listen. So the reference angle is always going to lie in between 0 and 90, right? Any doubt? Reference angle is always going to lie between 0 and 90. If I want to find the value of, let's say, 190 degrees, right? 190 degrees, it is going to be greater than 180, right? Or 260 degrees. Don't talk, please. Don't talk. If I want to find an angle greater than 180 like this, right? If I want to find an angle greater than 180, which is for instance phi, This is phi, right? Let's say I want to find the value of sine phi. Don't talk, please. First, I find the reference angle, okay, of phi, which is going to be something, say, theta. Theta is the reference angle. So, the modulus of sine phi is going to be equal to the modulus of sine theta, right? The modulus of sine phi is going to be equal to the modulus of sine theta because theta is the reference angle of phi, right? You don't follow? Because when we draw the triangle, we drop a perpendicular to the x-axis, right? So this is the triangle. Hey, don't talk. This is the triangle that we are concerned with, right? This is the involved triangle for the angle phi, but it is also the involved triangle for angle theta, right? The reference angle is theta, and for this particular triangle, sine phi and sine theta are equal in absolute value, right? But they are not the same sign. For instance, sine theta is positive, but sine phi is in the third quadrant, right? What is the value of sine in the third quadrant? Negative, right? So from here, sine phi is actually equal to oh my word, minus sine theta, where phi is in the third quadrant, right? Theta is the reference angle. Theta is the reference angle. To find the sine of the reference angle, you take it, you do it the way you have been doing in your 10th, right? You draw the triangle like this, you make this theta, and you use these sides. Theta is not the main angle, theta is the reference angle. Reference angle means you treat it the way you would treat a normal triangle. Did you understand? Not clear. We will do some exercise, okay? Find me the sine of 120 degrees.
or
120. Huh? Okay, I will demonstrate. Observe. 120. Yes. Not 1 by 2. No. So all silver teacup, sine is going to be positive in the second quadrant. It's not going to be minus 1 by 2 or 1 by 2. So I will show you how to do this. Observe. Let us take 120 degrees first, right? Let us take 120 degrees first. This is 120 degree, right? Which is the reference angle here? This is 120 degrees and this is 60 degrees, right? The reference angle is 60 degrees. So if you take this particular triangle, if you take this particular involved triangle over here, where you drop the perpendicular like this, if this is R, this is Y, and this is X, minus X, I mean. What is going to be Y by R? clearly the angle here is 60 degrees. What is going to be y by r? Sine 60, right? It is going to be root 3 by 2. Sine of 120 is going to be the same thing without any change in whether negative sign or positive sign, because sine is positive in the second quadrant, right? Are you following? So this is going to be root 3 by 2. What about this is equal to sine 120 itself? What about cos 120? Minus x by r, right? Negative 1 by 2, right? Excellent. Can you find what is cos 150? 150. Yes. One second. Yes. ഇങ്ങനെ ഒരു സംഭവം ഉണ്ടെന്ന് വെച്ചു. ഇതാണ് മെയിൻ ആംഗിൾ. റെഫറൻസ് ആംഗിൾ ഇതാണ്. എക്സ് ആക്സിസുമായി ഉണ്ടാക്കുന്ന സ്മോളസ്റ്റ് ആംഗിൾ ആണ് റെഫറൻസ് ആംഗിൾ. യെസ്, അത്രേ ഉള്ളൂ. ഇത് 150 ആണെന്ന് വെച്ചോ. ഇത് മുഴുവൻ 150. ഇതെത്ര? 60 അല്ല. സോ 150 ഇങ്ങനെയല്ല, സോറി. 150 വരയ്ക്കണം. ഇതാണ് 150, റൈറ്റ്? 150 will be less than 180. So ഇങ്ങനെ ഇരിക്കും. This is 30. Reference angle is 30. Cos is going to be negative in this terminal, in this quadrant.
So negative root 3 by 2.
Negative root 3. അത്രേ ഉള്ളൂ. So this is not 60. This is 30. This is 30. Yeah. For sine of 120, this is 60. Yeah. But for sine of 150, this is 30. മറ്റേ ക്വസ്റ്റ്യൻ മനസ്സിലായില്ല. So reference angle is 60, right? So the modulus of sine 120 is going to be root 3 by 2 only, because the angle is 60, but sine is positive in this quadrant, right? So it is plus root 3 by 2. What is cos 150? Were you able to find? Yes. Okay. What is sine 150? One by two, not minus 1 by 2. Sine is positive. Sine is positive in the second quadrant. Alok, give me a reasonable angle. Oda. Okay. Find me the sine cos tan of 300. Find me the sine cos tan of 300. So which quadrant is 300 going to be in? Yes, go ahead. Eh? What did you say? Allah. You found? What is sine 300? And cos 300? Where is 300? Not fourth quadrant. C. Castle C starts in the fourth quadrant. Yes. 30. 30. Sine 300? Allah.
Sin phi equal to minus sin theta മാത്രം മനസ്സിലാവില്ല.
Theta is the reference. Quiet down, please. Theta is the reference angle. Theta is going to be between 0 and 90. Sin theta is going to be some positive value, right? If I take this theta and find the sine, it is going to be the in absolute value equal to sin phi. But it is going to be some positive value, right? Because it's between 0 and 90. Don't talk, please. It is going to be between 0 and 90. But sin phi is in the third quadrant where sine is negative. So to make them equal, I have to put a minus sign. Did you understand? Give me one more. No, not you. Eh?
Sir, cos 300 minus 1 by root 2, sin 300 minus root 3 by 2, tan 300 root 3.
Hmm.
Sir, 280.
Okay. Find me cos of minus 30. Minus 30. Hmm? What did I ask? Cos minus 30. Yes. Yes, root 3 by 2. What is sine minus 30? What is sine minus 30? Hmm? Yes. This is negative. Okay. So you know now how to find sine, cos, tan of angles greater than 90 degrees? Right? Okay. So let me ask you a question. Can you find sine 75 degrees with this information? You cannot, right? So I will give you another piece of information, right? We will try to find out what sine of theta plus phi is. Is this sine theta plus sine phi? No, right. We will try to mathematically figure out what is sine of theta plus phi. So how do we do that? First, let us draw the triangle. Don't talk, man. Too much noise. Okay, we have drawn two clowns. Listen carefully. This is a proof that will not be repeated most probably, right? So this is the one time you are going to see it. So let this angle be theta and let this angle be phi. We know what sine theta is, imagine. Okay, we know what is sine theta, we know what is sine phi, but we don't know what is sine theta plus sine phi. Alright? So in order to find what is sine theta plus sine phi, we need to drop a perpendicular from this point down like this, right? So whatever is the length of this dotted line divided by the hypotenuse here is going to give me sine of phi plus theta. Any question? No, right? Okay. So what is this length? Before that, let me tell you that the hypotenuse of the first triangle that I drew is h1, and the hypotenuse of the other triangle on top of it, which is of angle phi, is h2. Okay? So what is this height? In terms of h1, theta, phi and h2. No, not h2 by h1. What is this going to be? So whatever this is, imagine this is something x. What is x by h1? What is x by h1? Imagine this is x. What? Yeah, it is x by h1 is sine theta. So from here, x is equal to h1 sine theta, right? This is h1 sine theta. Similarly, what is this height? How do you find that out? So I will tell you how to find that out. So we know that this angle is theta. What is this angle? 90 minus theta. This angle is also 90 minus theta. What is this angle? Why? Because it is a right angle triangle, right? Are you following? So what is this angle? That is also theta, right? You know what? Let's name the triangle. This is point A, this is point B, C, and D. And this is going to be E, and this is F. If you look at the triangle DEC, if you look at the triangle DEC, it is quite clear that angle EDC is theta, right? You know that that angle is theta. Now tell me, what is DF? So our final result is sine of theta plus phi, which is equal to dg divided by h2, right? That is what we want to find. So in order to find dg, we have already found fg. To that we need to add df, right? Now df by dc is what? What is df by dc? Cos theta, right? So we know that df by dc is equal to cos theta. But what is dc? h2 sin phi. h2 sin phi. Are you following? Are you following? df is equal to h2 sin phi cos theta, right? Clear? Any doubt? So what is dg equal to? What is dg equal to? h1 sin theta plus h2 sin phi cos theta, correct? So what is sine of theta plus phi? dg divided by h2, right? So this is going to be equal to h1 by h2 sin theta plus sin phi cos theta, right? Following? No. So I just struck off the h2 here. I divided this by h2 and this also by h2, right? And dg by h2 is sine of theta plus phi from the figure. How many of you are not following? You are trolling? Did you follow? Okay, listen. I will start from scratch. Listen. So we need to find sine theta plus phi, right? So we have drawn two triangles, right? One is with an angle theta, the other is with an angle phi. We have placed one triangle on top of the other like this, right? Such that this angle is theta plus phi. In order to find theta plus phi, we have created a triangle with the angle theta plus phi by dropping the perpendicular from D to line AB, right? We have dropped a perpendicular from D to line AB. It has intersected at point G. Clear? Okay. So now our task is to find DG divided by AD, which is going to be the sine of phi plus theta. Right? Now AD we are going to dub it as H2. It is the hypotenuse 2. Okay? We know its length. H1 is hypotenuse 1. Alright? So our task is to be able to find dg, and then we have to divide by h2. We will find sine phi plus theta. Right? Are you clear on that? How many of you are not clear on that part? Everybody is clear on that? Okay. So in order to find dg, we draw a line parallel to AB at C. We draw a line parallel to AB at C, and here we have another right angle. Right? Right? You are following that part? So now we need to find the value of df plus fg. Once we find the value of df plus fg, we will find the value of dg. Now fg is the same as cb, right? Because these two lines are parallel, AB and FC are parallel, right? CB is the same as FG. So what is CB equal to? H1 sin theta. Any doubt why CB is H1 sin theta? No. CB is, yeah, FG and CB are parallel. Therefore, I mean, no. Because they are intersected by the same two parallel lines, right? FG is the same as CB. This is a rectangle. CFGB is a rectangle and its opposite sides are equal, right? So we need to find CB. Why is CB equal to H1 sin theta? Yes, yes. So you know that that is H1 sin theta. Now we have found that angle FGC is theta. How did we do that? We took that angle AEG is 90 minus theta, right? Angle AEG is 90 minus theta. Therefore, angle DEC should also be 90 minus theta, vertically opposite angles, right? So in triangle DEC, one angle is 90 minus theta and the other angle is 90. So what is the remaining angle? Theta, right? So angle FDC is theta. So now what remains is to find DF. You want me to slow down? Okay, yeah. Write it down. Angle FDC equal to theta. Everybody got this far? Okay. In triangle ADC, What is DC equal to? In triangle ADC, oh my word. In triangle ADC, DC equal to H2 sin phi, right? In triangle DFC, in triangle DFC, DF is equal to what? DC cos theta, right? Following? This is equation 1, this is equation 2. Substituting 1 in 2, we get df is equal to h2 sin phi cos theta. Day samsarikya srodhige, right? h2 sin phi cos theta is df. Now what is fg? h1 sin theta, right? fg is equal to h1 sin theta. dg, which is what we want, is equal to df plus fg, correct? This is equal to h1 sin theta plus h2 sin phi cos theta. Any doubt so far? No doubts? Okay. Now we need to find dg by h2. What is dg by h2? Sin phi plus theta, right? So sin phi plus theta is equal to dg by h2, which is equal to h1 sin theta plus h2 sin phi cos theta divided by h2. Now what is, no, we will separate the term first. We will write this as h1 by h2 sin theta plus h2 bye, we get sin phi cos theta, right? Any doubt? Now look at the figure and tell me what is h1 by h2. Advaide following ille. What is h1 by h2? Eh? In terms of sine of phi and theta, what is h1 by h2? Cos phi, right? So we can replace this with cos phi. So this becomes equal to, or I will write it here, right? We get that sine of sine of theta plus phi is sin theta cos phi plus cos theta sin phi. You will only have to remember the result, but it is good to know the proof as well and to know from where it came from. Are you pulling his fan? Okay, okay, chill, chill, chill. That is going to be the next task for you people. By the way, before that, what is cos of minus theta? So did you write this down? I'll give you that later. Did you write this down? All of you, write it down.
H1 by H2 over there, overs are cancelled out.
So h1 by h2 is not cancelled out. It is cos phi. h1 by h2 is cos phi. This is the final result.
They are using Advait's tip, and the tip does not mean advice.
Taken it down? Okay. How many of you are following the class so far? Who are following? Why is your hand half up? You're not following? You're following, okay. How many of you are not following? What? You're not following. Okay. How many of you find it better to your speed than last class? Okay. Eh? Huh? Okay. Are you guys done? Okay. Okay, listen now. What is sine of minus theta? Sine of minus theta is minus sine theta. Right? This always holds. Think that theta is some angle between 0 and 90. What will happen? Minus theta will lie in the fourth quadrant. What will be the reference angle? What will be the reference angle of minus theta? The reference angle of minus theta will be theta itself, right? This will lie in the fourth quadrant. So sine minus theta will have to be negative, right? Because in the fourth quadrant sine theta is negative. So sine of minus theta is minus sine theta, all right? What is cos of minus theta? What is cos of minus theta? You there, you. What is cos of minus theta? That is incorrect. What is cos of minus theta? Cos theta, correct. Why is it cos theta? So do you remember all the drama that we did here? Cos of minus theta will be in the fourth quadrant, right? Cos of minus theta will be in the fourth quadrant. What is the reference angle of minus theta? Theta, right? The reference angle of minus theta is theta. So since it is in the fourth quadrant, is cos positive or negative in the fourth quadrant? Positive. The cast rule either starts like this, or you can start from here and say all silver tea cups, right? Cups see cosine. Cosine is positive, so it has to be too fast. Yes, it can come in the third or second, but then the rule will still be the same. This is more or less a trick for you to remember, right? Cos of minus theta is cos theta and sine of minus theta is minus sine theta. What about tan of minus theta? Minus tan theta, right? So now I need you guys to find out the value of sine of theta minus phi. What is the value of sine of theta minus phi? Solve.
In those three first cases, theta has to be less than 90, right?
No, the so in these three we have taken the example for theta to be less than 90, but we can generalize for any value of theta. These expressions are true. All right, for any value of theta these expressions are true. What did you get? Yes, it's right. 4 quadrantiലും the top 3 formulas work. What the hell is wrong with you? Have you gone insane? Your own slipper. Utter brain damage. If you want to, but you don't have to. Yes, that is why I have given those to you, right? Eh?
So,
What? Yeah.
but this minus sign is only for phi, right?
Yes.
So will you do this sin phi as minus sin phi?
Yes.
That's it?
That's it.
Yeah.
Alok, what is the answer? What is the answer?
Cos theta.
അത് തെറ്റാണല്ലോ നീ പറഞ്ഞ്. Yeah. Did all of you get this? You've got this. Okay. Now, what is the time?
3:10.
Find out the value of sine of 2 theta. Find out the value of sine of 2 theta. Yes, what is the final answer? Yes. Did you find the value of sine 2 theta? Huh? You substitute in the earlier equation sine theta plus phi, right? Phi equal to theta. So you have an expression for sine of theta plus phi, right? What happens if you plug in theta equal to phi?
Theta becomes phi.
Yes, this becomes sine of theta plus theta sine 2 theta. Do it. How many of you found sine 2 theta? You have no idea. Fine, what is it? Yes. Huh?
How did they get the value? 2 theta.
They said 2 sine theta cos theta.
And how did they get that?
What is sine of phi plus theta? Show me. Sine theta cos phi plus cos theta sine phi. This becomes, when theta equal to phi, this becomes sine theta cos theta plus cos theta sine theta.
When theta equal to phi.
Yes, sine theta cos theta plus cos theta sine theta. The two terms are equal. So it becomes 2 sine theta cos theta. Understand? Eh?
Oh, he's asking like,
ഇത് കണ്ടോ തീറ്റ ഈക്വൽ ടു ഫൈവ് ഇട്ട എന്ത് കിട്ടും അല്ലെങ്കിൽ ഫൈന് വരെ നീ ഇവിടെ തീറ്റ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യും സൈൻ തീറ്റ പ്ലസ് തീറ്റ സൈൻ 2 തീറ്റ ഇസ് ഈക്വൽ ടു സൈൻ തീറ്റ കോസ് തീറ്റ പ്ലസ് സൈൻ തീറ്റ കോസ് തീറ്റ guys to find sine 2 theta you have a previous expression, right? Sine of phi plus theta. In that you substitute theta equal to phi. Did you get it? How many of you got sine of phi plus theta? I mean 2 theta. Sine 2 theta. Okay. You have homework today. Go home and solve for cos of phi plus theta. Okay. Solve for cos of phi plus theta. Yes. Yes. This is general term, right? This is general term. General term. Now find me the value of sine 75. Yes. Eh? കാണിച്ചേ? Yeah. Teja, are you following? Are you following? So can you find sine 75? എന്താ ഫോങ്കോ? Show me that expression again. Huh? You found cos. Okay, okay. Continue. How many of you found sine 75? You found it? Yes, good. Did you guys found sine? Yes, good. Did you find sine 75? Good. Yes. Yes. What the hell is this? Okay. This is simply sine of. Did you find it? Okay. Yes. 1 plus root 3? Look, this is 1 plus root 3 by 2 root 2. Both have the same denominator here. Okay, now we will formally move on to vectors. Okay, remember your homework. Please do that. Find cos of phi plus theta. Now, you know what a vector is, right? You know that it has a head and a tail. You know that the length of the vector is its magnitude. Okay. So when we add two vectors, right? You know that most vectors are free vectors, right? They can be slid parallel to themselves. You know that? So are you clear with the laws of vector addition? You're not clear with the laws of vector addition. Okay. So how do we add vectors? There are two ways in which we can add vectors. One, let's say there is one vector like this, and there is another vector like this, right? The first thing that we need to do is either one of two things. Either we need to grab this vector, oh my word. Either we need to grab this vector and place it at the head of the other vector, right? Either we need to do this, so we need to slide it parallel to itself, right? Remember, free vector can be slid parallel to itself. We need to slide it parallel to itself until the tail is on the head of the other vector. Or we need to slide it parallel to itself such that the tails coincide, right? If we slide it parallel to itself such that the head coincides with the tail, then we use something called triangle law of vector addition. What is triangle law of vector addition? If this is vector A, this is vector B. You remember what this notation is? Notation of vector A and notation of vector B. I draw a bar on the top, it means it is vector A. The sum of A plus B is going to be like this, right? From the tail of A to the head of B. This vector is going to be vector A plus vector B, right? Now, what is going to be the magnitude of vector A? Mod A, right? What is going to be the magnitude of vector B? Mod B. What is going to be the magnitude of vector A plus B? Mod of A plus B. Now, interestingly, it is not going to be equal to mod A plus mod B, right? It is going to be equal to mod A plus mod B if and only if the angle between the two vectors is 180. No, 0, right? If and only if the angle between the two vectors is 0, is it going to be mod A plus mod B equal to mod A plus B. Otherwise, mod A plus B is not equal to mod A plus mod B. Clear? So how do we find the modulus of A plus B in terms of mod A and mod B? Do you want me to go over the proof again? You want to waste more time? So how many of you, other than the clowns in the back bench, want me to go over the proof again? Okay. So here, the proof is done using the parallelogram law of vector addition, right? What is the this is the triangle law of vector addition, right? This is the triangle law of vector addition. What is the parallelogram law of vector addition? The parallelogram law of vector addition says both are same, but what it says is that, stop singing. You have to draw lines parallel to the first vector from the head of the second vector, right? You have to draw a line parallel to the first vector from the head of the second vector, and you have to do same drama on the other side as well, right? And this will form a parallelogram, right? You can see that this forms a parallelogram. A clowns. You draw a line from the tail of both vectors to the new point, you will get a plus b, right? So this is a, vector a plus vector b, where this is vector a and this is vector b. Okay, so how do you find the magnitude of a plus b? So you extend this line. You extend this line and then you drop a perpendicular. So this is just line, okay? You drop a perpendicular from that point to the other line like this, right? Are you listening? So if we can find the length of this side and the length of this side, we can use Pythagoras theorem to find the length of a plus b, right? Length of a plus b is the modulus of a plus b, right? What is the length of, let us call this point P, this point Q, this point R, and this point S. What is the length of SQ, by the way? SQ is mod A, right? Because this is a parallelogram. Opposite sides of a parallelogram have equal length. SQ is mod A. What is QR? So SQ is equal to mod A. What is QR equal to? So if this is theta, then this is also theta, right? QR is equal to mod A sin theta. Correct? What about PR? It is going to be mod B plus mod A cos theta. Right? So we use Pythagoras theorem in the sense that mod of A plus B is going to be under root QR square plus PR square, right? This upon simplification is going to be equal to mod A square plus mod B square plus 2 mod A mod B cos theta, where theta is the angle between the vectors when you place their tails together, the smallest angle between the two vectors when you place their tails together, right? That is theta. So the modulus of A plus B is equal to under root mod A square plus mod B square plus 2 mod A mod B cos theta, where theta is the angle between the two vectors. Theta is the smallest angle between the two vectors when you place them when you join their tail ends, right? So for instance, if there are two vectors like this, This is not the angle between the two vectors, right? The angle between the two vectors is this one. Did you follow the proof? Okay. Now I have a question. Let's say that the angle between two vectors is 120 degrees. Okay. One vector has magnitude A. This time A is a positive scalar. One vector has a magnitude A, the other vector has a magnitude 3A. Or let's not be 120, let it be 150. Two vectors are there who have an angle between them 150. I'll write the problem down. Two vectors have an angle between them of 150 degrees. If the modulus of this is A and the modulus of this is 3A, find the modulus of the resultant. Find it. Yes. Yeah. What is cos 150? What is cos 30? Root 3 by 2, right? Minus root 3 by 2. This is not into half. No. What is cos 150? Reference angle is 30, right? But it is in the second quadrant, so it is minus cos 30. Secondly, cos 30 is not 1 by 2. Cos 30 is root 3 by 2. 10a square minus? No. No. You made some serious mistakes here. A, B is 3 times A, that's right. But you have to take root in the end. This is not correct. It is root of this. തെറ്റിപ്പോയടാ കോസ് 150 എത്രയാ കോസ് 150 അല്ല സെക്കൻഡ് ക്വാഡ്രന്റ് അല്ലേ Uh, what? Sure. The cos 180 or 150. This is 180 minus. Yeah. Hmm. 3 root 3 ആണ്. Yeah. Hmm? Yes. This is the answer. Did all of you get this? Huh? So it's 2 into 3 allada. It's 2 mod A mod B cos theta. You have written mod A mod B into cos theta. But first of all, cos theta is wrong. It is minus root 3 by 2. It has to be 2 mod A mod B cos theta. You forgot the 2. Eh? എടാ റൂട്ടിന്റെ വെളിയിലെടുത്ത് ഞാൻ ഏ ഏ യാ നീ റൂട്ടിന്റെ വെളിയിലല്ലേ എടുത്ത സോ ഇറ്റ് ഹാസ് ടു ബിക്കം എ ഏ വേർ ഡു ഐ what so let's start from here it is a square plus 3a square plus 2 mod a mod 3a cos theta what is cos 150 minus root 3 by 2 this is 9a square plus 1a square 10a square minus 3 root 3 a square write it down no so it is going to be root over mod a square plus mod 3a the whole square plus 2 mod a mod 3a into what is cos theta minus root 3 by 2 right by 2 by 2 by so this becomes equal to root 10 a square minus 3 root 3 a square a into a square right you take a square outside this becomes a root 10 minus 3 root 3
So we won't care about this mod.
huh
So we
so
won't.
yes there is a mod there I just skipped it No, Indila, in the question, A is the modulus. The vector is not vector A plus 3A. This is just 4A. Vector A plus 3 into vector A is 4A. These are two different vectors with different angles, but they have modulus is equal to A and modulus is equal to 3A. A is a scalar. You understand? So there is no mod here. So you have two vectors. Question is like this. You have two vectors, P like this, Q like this. Mod P is equal to A, mod Q is equal to 3A. So listen, I forgot some clowns. This will be done in maths, but I will briefly go over it. What is sine of 90 minus theta? Do you remember what is sine of 90 minus theta? Cos theta. What is sine of 90 plus theta? It's again cos theta, right? For all of these questions, 90 minus theta, 180 minus theta, 180 plus theta, 270 minus theta, the trick is to assume that theta is between 0 and 90, okay? These equations, for example, sine of 90 minus theta is going to be cos theta, whatever the value of theta. But you can imagine for your ease of calculation that it is between 90 and theta, right? So what is sine 90 plus theta? Sine 90 plus theta will have a reference angle of 90 minus theta, right? When I draw 90 plus theta like this,
And how do we find sine 90 minus theta?
that is cos theta.
And how did we find that?
You learned that in 10th, right? This is theta. This is 90 minus theta, right? For this triangle, the opposite side becomes the adjacent side, right? If you look at these two triangles, when you switch to 90 minus theta, the opposite side becomes the adjacent side. Did you understand? Did you not learn that sine 90 minus theta is cos theta?
We did for CBSE.
That your maths teacher will teach you. I am done. Let's go back to vector. Okay. Now let us imagine that I have two vectors which have a angle of, give me a reasonable angle, Fijo. That's actually reasonable because you can find sine 15, right? It's just sine 45 minus sine sine of 45 minus 30, but it's too tough. It's too tough. So we will make it 120 degrees. Okay? We will make it 120 degrees. You have, and don't yell out the answer if you know. I'm talking to you clowns over there. Don't yell out the answer if you know. Where is the other guy, by the way? Saeed. Eh? Oh. I have two vector. I have two vector at 120 degree angle to each other, right? This vector is P vector. Don't talk, please. This vector is Q vector. Mod P vector is A, right? If P vector plus Q vector is perpendicular to P vector. Find mod Q vector given angle between P and Q is 120 degrees. Chew on that. So my figure is a little geometrically misleading. I have drawn it like that on purpose. Draw your own figure. Poda. Kiska finger? Bloody fool. When I was studying here, we had a chemistry teacher, and every time somebody was absent and their excuse was fever, sickness, he would ask, "Kiske saath?" Kiske saath? With whom? Kiske saath? Aarude kude? STD. Yeah. Eh? Dot product എന്തിനാ? എടേ പോടേ, പട്ട് വല്ലതും ഉണ്ടോ? ട്രയാങ്കിൾ ഉപയോഗിക്കും മണ്ട. You stabbed this in the. പെൻ ഫൈറ്റ് കളിക്കുകയാണോ? Did you get anywhere? Did you get anywhere? Okay. Go back there. So were you able to solve? So here you have been using, listen, here most of you have been trying to do under root mod p square, which is a square plus mod q square plus 2 mod a mod b cos theta equal to something, then you are getting stuck. Just use triangle law of vector addition. Just use triangle law of vector addition. I just taught you that, you clown. So this is P, right? It has a modulus of A. I am going to draw Q like this. Instead of drawing it with their tails attached, I am going to draw it with the head of P connected to the tail of Q. Right? What is this angle? It's not 120. This is 60 degrees. I drop a perpendicular to the tail of Q. This vector is going to be P plus Q. Right? This vector is going to be P plus Q. And it is going to be perpendicular to P. Right angle triangle. Can you find me the modulus of Q? It is 2A. It is 2A. Right? Okay, next question. How to solve it? Listen, if you did not follow, to solve this particular problem, instead of using parallelogram law of vector addition, use triangle law of vector addition. You place this Q vector with its tail on the head of A, right? Like this. You place the the P vector like this and the Q vector like this. What is going to be the sum? This one, right? This is going to be P plus Q. Any doubt? Angle is going to be 90 degrees. What is this angle? 60 degrees. So if this side has length A, if this side has length A, this side should have length 2A. Cos 60 equal to 1 by 2. Sorry. Mod Q is equal to 2A. Yes. I used a geometric solution to this, right? So now do the reverse. Okay, good luck with that. Now do the reverse. Do the reverse. If you have vector of modulus A and another vector of modulus 2A at an angle 120 degree to each other, find the modulus of that vector. Find the modulus of that vector. Write down. Pay attention. You have two vectors. One is mod Q equal to A and the other is mod P equal to 2A, or let's say, yeah, doesn't look correct. The resultant vector is going to be like this. The resultant vector is going to be like this. You know this, right? Find the magnitude of the resultant vector. We just did it. We just did it that the resultant vector will be like this, right? We just did the previous problem. This is 120. I forgot to mention that. The angle between the two vectors is 120. Yes, this is 90. But don't use that information that this is 90. Don't use the information that this is 90. Instead, Just use the information that the angle between the two vectors. Just use the information that the angle between the two vectors is 120. What? 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 That's a medical miracle right there. Doesn't matter. Solve. The board is acting weird. Find the magnitude of the vector. Yes. Simple question ആണ് രണ്ട് വെക്ടർ ഉണ്ട് ഒരെണ്ണം is twice the magnitude of the other they are at an angle 120 degrees find the magnitude of the resultant അത്രേ ഉള്ളൂ yeah അതൊക്കെ റെക്കോർഡ് ആവും നീ ജെനുവിൻലി ഒന്നും കൂടെ കാണുമെങ്കിൽ നീ ക്ലിപ്പ് ചെയ്യാൻ എന്ത് കുന്തം വേണം ചെയ്തോ yes null vector were you able to solve this Indira huh? You forgot to take the root again 2a അല്ല we just did that in the previous problem right we did that in the previous problem if mod p is a the angle is 120 the angle between the two vectors is 120 then for some value of q this will be perpendicular right that value of q we found is 2a so I have given you the same question but backwards I gave you the angle I gave you the vector right I asked you to find the resultant the magnitude of the resultant no just use under root a square plus b square plus 2ab cos theta yes June 5th okay so before you go how much did we hey okay before you go let us briefly revise what we learned so Indila what did we start with what stand up what did we start with we started with a reference angle that is right what else yes then what sit down Bharat after sin phi plus theta what did we do then what Okay, sit down. Huh? What is your name? What? Yes, you. On a scale of 1 to 10, how much did you follow this lecture? 8. Okay, sit down. What about you, Teja? On a scale of 1 to 10, how well did you follow this? 10. Brilliant. I will I will ask you questions tomorrow. On a scale of 1 to 10, how much did you follow? 7. On a scale of 1 to 10, how much did you follow? Huh? Okay. I have been writing this for a year. Okay.
Yesterday you gave me some problem.
Eh?
Yesterday sir given the exam.
Hmm.
This is the right answer.
Yes, that is correct.